Incorporates both a 30, 60, 90. I can tell from this angle and the right angle. I have a 30, 60, 90, and then because these two sides are equal, I also have this isosceles right, or 45, 45, 90 triangle. And so if I'm told that BD is 8, I can go through and use the properties of those two special triangles to fill in the remaining pieces. So I take my hypotenuse, divide by 2, multiply by root 2, so that's the length of each of these sides. Now in looking at my 30, 60, 90, my side opposite 30 degrees is 4 root 2, so my hypotenuse would be double that, and the side opposite 60 degrees is going to be 4 root 2 times root 3, which gives me 4 root 6. Okay, so I use my special properties for those triangles, and now I can find my areas. I have two triangles that I'm adding together to get this quadrilateral. So I'm going to take my top triangle, 1/2 a base of 4 root 2, and a height of 4 root 6. And to that, I'm going to add my second triangle, which has a base of 4 root 2 and a corresponding height of 4 root 2. So these are my two calculations that I'm going to combine. So here, if I take this, I get 1/2 of 4 is 2. 2 times 4 is 8. And then in my radical, root 2 times root 6 is root 12. Okay, I do need to reduce that. Root 12 has a perfect square factor. It's 4 times 3, so that comes out as 8 times 2 times this root 3, or 16 root 3. So there's my first triangle. And then to that, I'm adding root 2 times root 2 is 2. Those cancel with this 2, so I get 4 times 4, which is 16. And so my exact answer, if I was looking for one here, would be 16 root 3 plus 16. There's no specific units identified. That would be my exact answer. If I was asked to put it in decimal form, I could do the calculation for this. 16 square root 3 plus 16. I'll put a decimal in here so my answer is displayed as a decimal. I get 43.71 approximately as my solution.